Welcome to Lonza Wood Protection in Conley, Georgia. With 150 employees supporting multiple business functions, Conley is the heart of North America's wood protection business. The site was built in 1973 and was acquired by Lonza in 2011 and has since continually updated this unique facility to meet customer demands. We operate on a model of customer intimacy and support, enabling the establishment of new treaters through equipment design and installation, the regulatory compliance of customers, and the reliable, short lead time to supply premium product to wood treaters all over the continent. Each of our facilities on our Conley, Georgia campus is securely fenced with access through a remote gate. The gates are monitored by the security staff located in and around the entire campus, including a main guard gate that is manned 24/7. Our technical center is a state-of-the-art facility that continually leads the industry with new innovations in the care and preservation of wood. Our 125,000 square foot facility sits on approximately 15 acres and houses 26 employees. Our tech center boasts 6 labs where our scientists provide analytical support to the residential, industrial, and wood specialties businesses, as well as to our customers. We monitor consumer compliance to AWPA standards and Lonza warranty specifications using samples of both treating solutions and treating wood our customers send in weekly. Those samples are analyzed for active ingredient concentrations using X-ray fluorescence analyzers and chromatography. Our pilot plant can treat wood on a small scale to simulate real wood application. It has 6 pressure vessels, 2 automated with our Treat Right computer system, 1 spray booth, 3 media mills, 1 homogenizer, and 1 par reaction vessel. The technical center is home to a fungal room where treated wood stakes are tested, a woodworking room with modern equipment, a spray applicator for surface application testing, and storage facilities. The Conley campus is home to an 8,000 square foot warehouse that holds spare engineering parts that can be quickly delivered to customers to minimize disruption to their operations. Our warehouse is also home to specialized test equipment, such as our mobile treating plant that is often dispatched to customer locations for on-site testing. Lonza Wood Protection's world-class engineering team is located in the administration building on our Conley campus. The team of 9 engineers with more than 200 combined years of experience designs, develops, constructs, commissions, and supports systems that utilize Lonza products. The group consists of all engineering disciplines and supports technical services, the sales team, and our customers at more than 100 wood treating plants in North and Central America. Behind our administration building is our line of poles treated with varying chemistries. We use linemen from regional utility companies to periodically climb these poles treated with our preservative formulations to test against those of our competitors. These tests have been conducted for 35 years. Lonza Wood Protection owns and operates a fleet of trucks that transport our products from not only our Conley campus, but also our other North American facilities located in Valparaiso, Indiana, Colima, Washington, and Richmond, British Columbia. Our fleet consists of 70 trailers, 21 tractors, 2 straight trucks, and 4 yard trucks, and our capacity includes bulk, LTL, exports, and rail. Our on-site repair shop can hold a 48-foot container and has overhead coverage. Resting on approximately 25 acres, Lonza Wood Protection's manufacturing facility is comprised of 9 buildings, where our experienced workforce of 30 operations and maintenance employees manufacture raw ingredients and finished products used in the preservation of wood. The facility consists of the copper oxide plant, the arsenic acid plant, the micronized copper azole plant, the warehouse, the railcar depot, and the mix plant. Copper oxide is made in the copper plant in reactor R1200. It is a dry, solid cake that is an intermediate product used in the on-site manufacture of CCA. The process involves charging water, ammonia, and copper metal to the reactor and sparging it with oxygen. The copper oxide slurry is dried using a rotary vacuum filter, packaged into 2,200-pound super sacks, and stored in the mix plant warehouse for use in the manufacture of CCA. Micronized copper is an intermediate product made in the microplant. The process begins by charging water and BCC, basic copper carbonate, into a mixing vessel with rust inhibitor and dispersants. The material is then mixed using high-shear mixers to deagglomerate all the particles before being routed through one of two of the largest available vertical bead mills on the market in the USA. Here, it is milled to a preliminary intermediate specification before being passed into one of 4 horizontal bead mills for final work to achieve the required final specification of a D99 of 0.725 microns. At this point, the material is transferred from the microplant and stored in bulk as an intermediate called micronized copper, ready to be used to blend into the finished product, MCA. In the microplant, MCA is manufactured with ingredients that include micronized copper, surfactants and actives, tebuconazole and propiconazole, directly to totes or tank trucks as required. This, like CCA, is then delivered all over the South, East, and Midwest to lumber treaters using our Lonza fleet and drivers to offload our material direct into the customer storage tanks. In the arsenic acid plant, arsenic acid is produced in reactor R500. It is a liquid and is also an intermediate product used in the on-site manufacture of CCA, chromated copper arsenate. Arsenic trioxide is delivered to site in drums and is discharged to charging hoppers using a sealed drum dumping room. The drums are then automatically triple rinsed to Resource Conservation and Recovery Act standards, crushed to prevent reuse, and put into a scrap dumpster. The process uses 2 reactors in series and involves reaction of an aqueous slurry of arsenic trioxide with nitric acid, potassium iodine, and oxygen. At the end of the reaction, the arsenic acid is sampled for concentration and transformed to bulk storage, where it will be drawn for use in CCA production. If any solids are detected during the sampling phase, the operators will route the material through an Oberlin platen press and belt filter to clean the material as it is sent to bulk storage. Chromic acid is made on site by the addition of water to chromium trioxide, supplied by rail and rolling reactors. The chromic acid is pumped off the rail car to a bulk storage tank ready for use in CCA manufacture. At the mix plant, CCA is made in 2 reactors. The process involves charging chromic acid, copper oxide, and arsenic acid to the reaction vessel. And following a set mix period, a sample is taken to the quality control laboratory for final analysis. Following QC sign-off, the material is transferred to bulk storage, where it can be loaded to totes, tank trucks, or rail cars for distribution. In the plant's quality control lab, approximately 3,650 batches and more than 1,250 analyses are performed each year. Employees use state-of-the-art equipment to determine the quality of the preservatives we ship to our customers. Samples are taken and tested before any product is allowed to leave the site. In 2019, the Conley facility produced 5 million pounds of copper oxide and 17 million pounds of arsenic acid for use in the manufacture of 47 million pounds of CCA. In the same year, we also produced 21 million pounds of micronized copper that was used in the manufacture of 27.5 million pounds of MCA. Every day at our Conley facility, products are made and transported to customers. Discoveries that assist in the creation of new and better preservatives are sought and made, and customers are thought of first as we provide technical, regulatory, marketing, and sales assistance. Our facility has undergone changes and upgrades that help us in our mission to provide the best preservatives available in the market today, always with an eye to the future of bettering our industry. Thank you for taking the time to participate in the virtual tour of our Conley campus.